Today I'm going to present about O&O, a DIY toolkit for designing and rapid prototyping olfactory interfaces. Among all human senses, olfactory perception features prominently in arousing emotions and memories. However, the use of smell is underexplored in the HCI field. Most of the research in the field were designed for specific applications or tasks, which led to challenges in extending their original capability to more scenarios. On the other hand, some commercial olfactory displays were not always accessible because of the high price and tech difficulty. In addition, there are limited open-source solutions presented. Hence, to overcome existing limitations, we presented O&O. As shown in previous research, designing an olfactory interface required a significant amount of design, fabrication, and engineering effort. The toolkit consists of the three main components: scent generation kit, module construction kit, and design manual. The module construction kit is a set of foldable cardboard templates that can be assembled into permutable functional modules to support three most common scent generation technologies: fan, heating, and atomizing. The toolkit provided a rich abstraction of primitive module forms and full specification of size choices to accommodate different use cases. So how the module works? Take the inner structure of the cylinder module as an example. The module efficiently packages different scent delivery functions in the capsule by integrating minimal scent container structures, scent sources, and output components. Instead of a non-extendable all-in-one interfaces, the toolkit implements a plug-and-play syncing into the form design that uses the formal modules on a custom structure defined by the designers. A lot of open-source foldable templates are available online for exploration. For example, the image presented a foldable cardboard scent-enhanced masks. To build this interface, the designers print and fold mask templates. The yellow holes indicate scent ports on cheeks that can later accommodate different scent delivery modules. In addition, the module construction kit also includes 5 prototypes of scent transmission modules that can control main characteristics of the odor transmission. In the scent generation kit, we designed 2 sets of driver modules for ultrasonic atomizers and output components supporting PWM control. All modules support manual and program control modes. To support the driving modules, the scent generation kit provided hardware selections containing optional accessories and output components. The third section of the toolkit is a design manual that resolves technical production from the lens of design disciplines by introducing a human-centered ideology supported by an accompanying 5-step decision-driving process and common design tools, such as the personal cards, storyboards, interactive questionnaires, illustrations, traceable paper templates, and evaluation forms. Then for self-evaluation, we built and highlighted 5 prototypes such as an aromatic mask or a scent notification watch. To gain preliminary understanding and feedback of the usability and creations of the toolkit, we conducted Study 1, a formal workshop, and Study 2, DIY on solo sessions. In Study 1, we recruited 19 participants and divided them in 6 groups. A pre-study questionnaire was given before the workshop. The workshop lasted about 4 hours. With the first 20 minutes, we presented a series of classical studies within this field. Then next 30 minutes, we instructed the use of the toolkit. Next 40 minutes, participants brainstorm in a group and form their ideas. Then they are given 2 hours to prototype. Finally, every group presented a 5-minute presentation. Then we give a post-questionnaire to collect feedbacks. As delivery, groups made distinguishable prototypes such as plant water reminder or olfactorization piano. In Study 2, we further evaluated if the toolkit supports more complex prototype systems, what users produced, and how they engage differently. 4 participants from the previous study volunteered to participate in the DIY on solo sessions with the extended time of 5 days. As a final delivery, P6 worked on a specialized equipment for olfactory training. Her prototype included design considerations such as scent selection, odor transmission properties, and input systems. P10 presented an odor-enhancing machine for Fruit Ninja game. P9 designed a Do Not Disturb alarm clock. P1 built an olfactory display that played scent to soothe emotions like anger or reduce symptoms of PTSD. To analyze the overall performance of the toolkit and user engagement in the workshop and the following DIY on solo sessions, we used a mixed method approach, including workshop videos and user creations, pre- and post-study questionnaires, and interviews that is transcribed and created thematic analysis. From the analysis, we acknowledge the toolkit's usability, versatility, and functionality. It supports more complex design and prototype requirements while stimulating the interest and empowering new audiences with a sense of accomplishment and engagement. It also embraces more disciplines to enhance creativity. We also identified its prospective application in STEM education. In conclusion, O&O is a DIY toolkit that reduces complexity, guide design explorations, empower new audiences, and enable replicacy beyond one-off application. For more discussion about the toolkit, evaluation process and methods, findings, and future implications, we invite you to check the paper and open-sourced files. Thank you.